In this video, we will focus how to instrument your Node.js JavaScript application with OpenTelemetry and how to send your logs and traces to otelig.com so you would be able to see the insights, create alerts, and browse the data. So let's go to otelig.com, click on How, and find Node.js application sample. Inside the sample, you'll find two parts, the dependencies and the instrumentation code. Let's copy the dependencies, and these are just standard npm packages. Let's install the packages. And once that is done, let's create a new file for the instrumentation code. I will call the file otelig, but you can do in any other name. Let's copy the code and paste that. Once that is done, on the top of the file, you will find a couple of configuration options. Your service name, your application name, but the one required field is the API key. To get the API key, go back to the otelig and create a workspace. Once the workspace is created, go to the settings and get your API key. Copy key, back to the code, and paste in the API key. Once you're done with this, you are done. And now the only thing missing is you have to include that into your application. So let's import into the app. And that's it. Make sure that you are importing your instrumentation as the first thing inside your application. So the instrumentation that would load first, and then the app. Now let's go ahead and run the app. You can see that my application has one warning and then one log message. If I would go to otelig.com, now inside my logs, I will see these two lines, my warning and my log. Now let's go to the Postman and make an API call. You can see that this API call took 84 milliseconds, but I clicked a couple of times and now the time goes down. The question is why? So let's go back to the to otelig, and you can see that there are more logs come in because I'm navigating my app. But inside the traces, let's see what is happening. Let's zoom into the last 5 minutes. And we can see that there are a couple of traces. All of them are the get method to the to-do list API endpoint, but one is taking 10 seconds. Let's go ahead and see what happened during the first call. Inside of it, we can see that the API was able to respond fairly quickly, but full trace took still about 10 seconds. It is 10,000 milliseconds, so this is about 10 seconds. The Postman showed us the initial call took about 70 to 80 milliseconds, which is close to this one. Postman also counts the networking between the API and the response. So that's why the trace is a little bit less than what the Postman shows. But the thing is that the full trace is taking about 10 seconds. So the question is, what happened? And in this place, you can see that the API responded to the GET request fairly quickly, but it was trying to make a bunch of TCP connections. Then it was trying to do a MongoDB find and MongoDB create. Let's check what it was trying to create. And it seems like it was trying to create a collection called to-do items. Then it was trying to create indexes. And this only took 70 seconds, but later on you can see that it was done and it was trying to make some more connections to the database. I have a MongoDB cluster running on the local host on all of these pods. So it seems like MongoDB automatically tried all those pods to make the connections. So that was what is called a cold start of the application. It was the first call to the MongoDB. It was trying to ensure that the collection is created. It was trying to ensure the indexes. While the indexes are created now, if I would go back to the IDE and would restart the application, now it is listening again. Let's go to the Postman, send new request. Again, you can see that the first request is about 8 milliseconds. Another request is way less. Let's see inside the traces what is happening. Inside the traces, we see the new traces. And again, the first one took about 10 seconds. Let's see what's inside. Inside of it, again, we can see that create indexes took just a fraction of the time, but then there was a huge delay until this happened. So what is happening in the code is basically we are getting the request to the to-do list API endpoint. Then all of these things happen. Then MongoDB is continuing executing on the background, even if it has already responded to the request. That's how you can see exactly what is happening with traces. Other requests are not creating the collection and is not creating the indexes. That is how Mongoose is built by default. You can modify that behavior with configuration options, but I'm using default, and this is how it works on default settings. The other calls to the to-do list, you can see that it is just calling the find query. It is using this database statement to get the list of the items, and it is just responding fairly quickly. Now what we can do more is we can stop the MongoDB cluster, and now it will not be able to log into the cluster. Let's make another call. I will pause for a minute because it will wait for about 30 seconds to respond. Okay, so API call finished, and you can see that it took about 30 seconds, and it ended up with the internal server error. Let's go back to traces and see what we can find. Inside the traces, you will find that there was a trace with a bunch of errors, 167 of those. Inside of this place, we can see the traces with errors, and we had none, 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 and suddenly we have one. To find the error traces, we can also use extended search. Click Add, errors count, more or equal to 1. Now we are looking only to the traces with errors. Also, we can, if we don't want to do this, what we can do is we can order by errors. In this place, at the beginning, we will see traces with errors as well. Let's go into this trace. And this trace is huge. It has almost 300 spans. The span inside the trace is one kind of operation. So for example, if you're making a request to a database, that's the one span. The first span is the get to-do list RESTful API request. The request took only 30 seconds. And inside the postman, you can see exactly that the request took about 30 seconds. But the trace is way longer. It is taking almost 80 seconds. So 110. So it is good. The application continues to run, and it tries to reconnect, and it is getting the errors continuously. So we can see at the moment it is 130 seconds. It will stop at some time, but it is continuing to run. We already have 284 spans in this case. So what the application is trying to do, what Mongoose is trying to do, it got the HTTP request to this to-do list. It was trying to connect to the Mongo database, but it was failing to do that. That's when the errors happen. And then it was trying to reconnect over and over again. It is just trying to get that connection. And it is failing and it's failing and failing. That's why we have a bunch of errors. We can click on one of those TCP connections to see what is happening. And we can see that this TCP connection is going to the localhost on the MongoDB IP, MongoDB port number. So we know for sure that this is to the Mongo database. You can see that it is trying different ports because it is MongoDB cluster. It is running on all of these three ports. If we go to the terminal, you will see that I was running my cluster on those ports. Let's restart the MongoDB. Let's give it a moment. Now MongoDB is up and running again. Let's go to the Postman and make another API call. I haven't restarted the app, and you maybe noticed that the response immediately was less than 18 milliseconds. So this one is finally done. It should be able to connect now, so no more errors now, because finally it connected. It was retrying for 240 seconds until it finally got it done. So now we can see that we only had this one trace with errors, and now the next ones are fine. We can add the average duration, and this one took about 30 seconds to respond, but the last ones were quicker. This one took only 11, 8, and 16 milliseconds to respond. So we can go ahead and click into it and see that it was just responding to the RESTful API request, and it was also making a MongoDB find query in the middle of that request. And once you select MongoDB span, you will be able to see exactly what was happening. So as you can see, we instrumented the code in a very quick way, and most of the video we were exploring more of what we can do with that instrumentation rather than instrumenting itself. So to instrument the code, it's fairly easy. You just go to the how, find your Node.js application sample, install dependencies, copy the code, and add your API key. And that's it. Happy browsing and happy debugging.